recording started. Okay, so today types, right?
I guess.
Okay, so man, we're gonna have to update the tests, man. I'm already sad, but okay. Uh,
But that's the whole point of the test, man.
it is E-unit, as far as I remember.
Yeah. Okay.
Yeah.
Let me
So
just see if this scrap is working. Yes, it is. Okay.
Oh man, it makes me a bit sick to look at Erlang.
Yes, it makes me
okay,
wanna.
so
I don't know.
what
Makes
was
me
this?
nauseous.
What was the strategy again? I already forgot what I even like. I said this. Pick put a list of types that to have some sort of like use the same function for multiple types of values or things, and then we have a list of those, and then we pick the list of arguments, and we see if all of them is first the same type, and second it is a type available in a list of types. And then if that's okay, then we proceed. Otherwise we just throw in a type error. That was this thing that I said. Is that correct, Nathan?
Can you repeat, please?
Yeah. So each function will have an extra argument, which is a list of types, which is the list of types that this function can be applied to.
Yeah, to start with, we could do the list of tuples. That way, we guarantee like stuff because the parsing, like, you always deliver the same amount of stuff,
Yeah,
right?
but why
Like,
a tuple and not a list?
because if you have two lists, the parameters and the types, then you have to like deal with problem that doesn't exist. Like, oh, what if they have like different what's the name? Length, but in actuality would not happen.
No, no, no.
If you
I
have
think no, no,
one
no,
list,
no. I think I didn't explain good enough the problem. So I will try start writing some in. I think you can see via Magetas, right? That I'm typing.
uh-huh.
Yeah. So my idea was we're gonna have a list of I don't know integer, rational, uh, whatever. For now it's
A
okay.
least.
Yeah, and then we're gonna have the list of arguments, which we don't know which they are. We just know they are a bunch of expressions.
Let me see.
So expressions here, and what we're gonna do when
Oh,
we have a function, the function will receive this extra argument, which is the list of types, and then what we're gonna be doing is we're gonna iterate through all the arguments, which in our case is a list of expressions because we have variadic functions. And then we're gonna see if first every single member like of the list of arguments if they have the same type, and second if this same type is inside this guy, and if
Wait,
those two
that's
those
so
two
weird. I don't think you
I,
need that. You
I,
don't need to have a list of types.
how are you gonna
I
do
don't
the
understand.
overloading for functions then for multiple types?
Overloading for
Yeah, because we're
function.
not gonna be doing like plus dot. Not gonna be doing that crap.
Why not?
No, but that um
So let's
You
suppose a plus,
prefer?
right? So let's suppose a plus. I want to be able to be doing plus with integers and rationals.
yeah, that's the thing. Oh, look at that,
Oh,
Magetta.
I
As we
see.
don't have operators, we cannot do the overloading unless we are doing
Mhm.
like system F because they are all functions.
Yeah.
Whew. You just can't let them.
No, but why we just
Yeah,
can't
we
just
can.
we just add another thing in these things, man. It's not
Yeah,
that
yeah,
that hard.
we can.
That doesn't.
I mean, yeah, we can. I see what you mean, right? Because you want to add all the possible things
Yeah.
for that.
Uh,
But I think the correct way to do this would be having something like a number, which is a higher type. And from this thing, you can just add it here. And then when you check the expressions, you eval the expression. Not eval, right? Sorry. You type check these expressions to see if they, uh,
I agree that subtype is better.
when evaluated, they go down to something that is inside this superclass number.
Oh, so the number would contain integer and rational or something like that.
Yeah, something like
So it's
this. Yeah.
kind of precarious, like a precarious way of doing type classes or something like that.
Well,
No,
that's not
wait.
precarious subtyping.
Wait, yeah, the listing, I didn't think much about it, but I'm pretty sure you will run in a bunch of problems, man, inside the body of the function. But I think that subtyping that Maget is suggesting can work. And basically, what changes is when you are like checking the equality of types, you just do that.
Yeah, but
Like the children is equal to
I
the
think that the
father.
subtyping approach is better, but I still don't see any problem with this other approach.
Yeah,
I
I
just think
mean,
this is dumber. Like, it's worse. But this is totally
Ah,
possible.
okay. Let me think about it.
It's totally more inefficient because you're gonna have to first check all of those and then compare with all of those, which is bad. But
what do you
which
mean
makes
by
it,
all of? Just one thing. Okay, you're thinking of variadic, right? That's
yeah,
what you're saying.
our
All of
plus, our
those.
minus, our
Yeah,
multiplications,
but
they're all
in that
variadic.
case specific, you are not even like attributing like one. How can I say? Because you have one type for each parameter, right? In this case, you are receiving only one parameter, and it is variadic. Is that the case?
No, let me put a more concrete example to make it clear. So let's suppose that we have a literal here. We're gonna have an
Hmm.
integer here, and we're gonna have one. That's fine. And then let's suppose that we have two, just for the sake of this example. So this is gonna like this. This will
Okay.
do the following. It will iterate through all of those and check. Do these have the same type? So integer, integer, and so
Hmm.
on. And then after all of that, we're gonna say, okay, we have all integers, which is great. Is integer of inside this? Because if it's not,
Yeah.
we cannot apply this to these.
So let me ask you something.
Yeah.
Why does that argument need to have all the same type?
Because I don't like the idea of like casting one
Hmm.
type to the other. That sounds bad.
But
Like
man,
imagine
like
having a
we
rational
have
here.
I
like
think you guys are talking about two different things. But go on, Nathan.
yeah, because you have like parameters in our language, right? So you can have like multiple
No, but yeah,
parameters.
but he's not talking
This
about multiple parameters. He's talking about the going, like he's talking about the variadic functions like plus,
Yeah.
evaluating everything. So this would be only
no,
one.
no, but
You see?
that's what I said. He's describing a situation where you only have one parameter and
Yeah,
it is a variadic.
I see the issue.
But okay, then you are in that situation and you have that
Yeah,
list.
but that's like a evaluation not for this specific case, right? This is evaluation for a list, like a generic list.
Yeah. In this case, but
Hmm?
I agree with Nathan that this mechanism we would need to think about a different mechanism for like different varieties, like 2 parameters, 3 parameters. That would be
Hmm. Yeah, but you always
No, no,
evolve
you
just to
don't.
one. You just focus on what the structure is. In the case of variadic, it's a list.
Yeah, like Lemus, I don't think you really don't. Like, if you deal with this case of, okay, the type for this is one of those, and the argument is this, if you solve this, like, you solve all of those, I guess. If it's variadic or not, if it's multiple or. What I want to think about is, okay, if I attribute one of those types, do I need to guarantee that it works for. Holy fuck! Okay, I think I saw. Uh,
Do you have
Oh,
loop?
that's so weird. Uh, like Lemus, you would have to check the body if the body compiles for all the possibilities of your parameters, man.
Uh,
To begin with, that would be cursed as
but I
fuck.
think we are already doing that, don't we?
Let's see here.
No, no, no. So take a look. Imagine that you have parameters and you have the body. Well, let's say how do you type a function? Abstraction, right?
Yeah.
You have the parameters types and you have the body that is expression. You
Yeah.
insert the parameters type with the parameters name in the environment,
Okay.
and then you use that new environment to get the type of the body, right?
Makes sense.
But if you have different possibilities on the parameters type, you need to go through all the possibilities and do the same process. Look how cursed that is, man.
But that's the thing. I think we are already doing that, man.
No, that is no way.
There's no way. Let
There
me
is no
check.
way.
Let me check evo abstraction here for a sec.
That would be so crazy because if you have different types in which the types are like either one or the other, you come up with a huge like Cartesian product of things that you that like possible bodies that you
Yeah.
need to
So
do.
each abstraction evolves to a closure eventually, and when we evaluate the closure, we are evaluating the bodies.
No, no, no. So first of all, we are talking about typing. Like evaluation, we really
Yeah,
don't care right now.
evaluation.
And the
No,
other
so you
thing
mean
is
type checking the bodies multiple times? That's what we're talking about.
Yes.
Oh, okay. Uh,
And I'm not even sure about the return type. Like, would the return time be different? And if so, it would also be a either. And in this case, would everyone need to treat that? That sounds like nightmare.
yeah, I'm having a hard time visualizing that. So can you try to send, I don't know, in the chat or maybe enter the session that with Mageta's link because
I would
Yeah, try
like
to
to
join
enter the
here.
session.
Yeah, try join.
What is the link?
is the last
The
link in
link
the
on the.
chat in this voice channel.
Yeah.
Yeah, so the problem is that you said that you need to type check multiple times the body. Multiple times.
I guess so. I could also be wrong
I
about that.
think we are talking about different things. I think Magenta got my
Yeah,
point. This is just
I
a just
I'm not
one
sure
use
now, man.
case about like variadic functions that can be applied with multiple types. That's all I'm saying. I'm saying here.
Why don't we start? Because here's the thing: we always need to check one to one, right?
Mm?
We
Mm.
But
always need to check just one to one, like one type to one expression.
one type to one
Oh.
expression.
Yeah, like every expression can only have one
Yeah,
type.
okay,
That's
that
the
makes
whole
sense.
Oh,
That
necessary.
makes sense.
yeah.
That makes sense.
So, in this sense, like thinking of the way you're showing there, like you're thinking of integer and rational as the two possible things to insert in that case, right?
Yeah.
Oh, that would break that.
So I
So
think this. So let's think. So this list here should be a type list int, right?
yeah,
Let's use integer. I hate the lowercase.
yeah.
So, mm, so the only thing we can match is that okay, a list is a special case because we're concerned with the thing inside, right? But wait, so the annotation here is different. It is this.
No. Wait. In my specific example, uh, that's interesting. But what I said, my intention, Maget, was the following: the plus is always expecting a list, right? So I was
Yeah,
referencing when I was
yeah.
writing this
The
guy, just the
element inside,
internal.
right?
Yeah,
Yeah, I see.
yeah, that's the thing. And then this guy can be or a list of integers or a list of rationals. And then if we iterate through these and we find
Yeah.
they first they're not
So okay,
compatible,
yeah,
then we're
because
done.
here's a separation of concerns that I was thinking. Like iterating over and checking if all of them comply with the same type. Like in this case, it would fail, right? Because one
Yeah,
is rational, another is an integer.
yeah.
Like in this case, it would fail, but it's not because of a plus. It would fail because of
Type
the
checking.
evaluation of a list.
No, it would be a type check error. This.
That pay attention to what I'm saying. It's not a type checking inherent from the plus function call.
Oh,
It's
okay, that
inherent
makes
from
sense.
the list declaration.
Yeah, okay, that makes sense.
So that's what I'm saying. We can separate our concerns by
Uh,
just
I think,
evaluating
hey, I think that
things
kind of Magita,
atomically.
because when we are
Mhm.
type checking a variadic function, you don't need to follow your type check rules for evaluating a proper list.
I don't get you. Can you go again?
So, like, we type check expressions, right? One of the expressions is a
Mhm.
list,
Yeah.
and it has a specific way to type check a list.
Yes.
But when we are type checking variadic arguments, it doesn't need to be the same rules as the list. So it's not as if you are doing the type checking and
What I'm
it will
saying here
fail
is
because of the
Yeah, but
list.
what I'm
why
saying
wouldn't
here
you do
is,
that, Manata, in this
dude,
case?
do you guys remember how to make like algorithms recursively?
Hmm?
Like we start with the base, like to define like recursion, like in paper, like literally in math, and then you just design the algorithm out of that. Like you always have to assume a base case, right, beyond that thing, and then you keep just going the recursion. So my assumption here is that when things are gonna get here, they are already type checked because I just type check the expression that I'm receiving with the type that I'm expecting. If it doesn't match, then
I understood what you said, Mageta. Did you
and
get
and,
Manata?
and let me
I
just
think
finish.
so, but I
And then
doesn't
the only
relate.
thing that we need to type check, and the only thing that would enforce, for example, this list in the case would be the primitives, because well, the list would be a primitive, right?
That would be very easy to do, but I want to understand Nathan's approach. So
So just take a look at this piece of the code, man. Like, oh wait, that's wrong.
just
Now
take a
it's
look. Oh, that's wrong. Okay. Uh, okay. So f is a function of type. Uh, holy man, this is a mixed bag of syntaxes right here. Wait.
well,
This.
we could use instead
Just
of
do
like
just
square
do a syntax
brackets.
in let's do in Silverware.
No, 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 wait, man. That will be worse, man.
No, what do you mean, man?
That will be more complicated to
No,
understand,
it
man.
won't. It
Yeah,
won't.
it will.
Please, Nathan, go on while Magetta attempts to write this in Silverware.
So, man, you see at this type here,
Yeah,
it's what you said. It's either one type or the other.
yeah,
I have the function f. It receives a x and it returns a x. It's like a identity, right?
yeah. It's
So,
identity.
what is the return of this function f? That's the type.
Wait. Oh no, but we never talked about the return type, Nathan. We never did that.
Well, but if you allow the parameter to be it, how can you constrain that the body will just not return one of those
No,
parameters?
in that particular case, what you're saying would be the following, I guess. So this is gonna be like this, but the return type would be an integer or a rational. That would be
Yeah,
the
a plus is a good a good symbol for that. But yes,
yeah. So this like okay, but okay. Now we have the
and by
return
the
type.
way, you kind of can do that, I guess. There is something called like polymorphic variants in OCaml, and it's kind of that. And basically, you could also do like variants normally, but without recurring like type declaration. You know, as you can only like use variants in Haskell if you declare them first. That doesn't need to be the case.
Yeah, but wait, let's go back a little bit. I want to understand what your approach of doing the type checking for the variadic functions. That's what I want to understand.
Okay, a easier point. Man, what you want is easily solvable by having like ADTs.
What I want is easily solvable by having ADTs. I don't see. I still think Mageta's suggestion is easier than that.
Yeah, it's
No,
like
no,
a
no, 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 wait.
drug
What
level
you
of complexity.
wanted, like, they are different things. I think the Magetta solution is really good, subtyping. It brings a bunch of problems.
No, no, no,
Like,
not that suggestion. What he suggests
hmm.
about using like instead
No,
of the
it
type.
goes. No, but it has subtyping as well
Yeah,
in
it
that.
has involved, but what you said was okay. Instead of doing all of that, let's just pick this list here, and let's try to type check this. And if this doesn't match, we are done. We don't have to do anything else. We don't even have to consult this.
Yeah, like in my point, I don't really care if it's a list, if it's variadic or not. I have like one argument and one type parameter, and if I can type that correctly, then like you can type all the rest, I guess.
Okay, so let's suppose that you have a function, the function f. You have your parameter, and we know the type that the parameter should have, and we know the type of the return of the function f. How would you do this? Like
You
how
know,
would you check this?
I don't know what you have to check. Like this is check it. You are saying you have the parameter type and the return type.
Yeah, but we also have this in this approach, right? We have the arguments, we have the types,
No, wait. Look at your first example. You were talking regarding I have the parameters type and I have an expression.
a list of
Using
expressions. This is a
well,
list.
a list of expressions.
Yeah.
Like either way, from that we need to get a return type, and that's the problem.
No, but the return. Oh, I see.
Like
Okay,
this
okay,
situation
okay.
right here.
Yeah, I understand. Oh, it's because if the return type of the function can be different, how are you gonna tackle that, right?
Well, you could return this thing, but that would be
Yeah, but
hellish.
wait. I have an idea. If we iterate through the list of parameters of arguments, and we know that they are all the same and they are here, don't we know already that the return type?
Man, no. Well, kind of. Okay, you have a good point. Kind of, yes. But That's the. Let me think about it.
I'm
Right?
not
If you have this
quite
function
sure.
I'm going
and
to just
then you
ignore
are
you both and start doing.
well, you could. Uh, Let me see. You have a function with this type, and it is a weird type, but then you are applying to something. You are actually delivering a type. Ooh. Yeah, but that would be not as straightforward. Oops, I'm following. Uh,
That
Let me see.
I'm not quite sure about what I
Wait,
said.
wait. I got lost. I was with the other page with my guitar. Uh,
Wait.
so okay, like in your example, you have the arguments and the function, right? Like in my
Yeah.
case, we only have the function because, well, you type the function to get the like return type of the function, right?
No, but in my
So
example, we only have three things in my example: the function, which you don't know
Just
what
one
it
thing.
is.
You're sharing what, Nathan? You're recording what? Because I'm doing another thing here.
No, I am recording and I am discussing with Nathan here. I'm not showing your screen right now.
Okay, because I am on the other file. But
Yeah,
anyway, go
okay.
on.
So Nathan, we have the same, not the same, but in my example, we have three things. We have the function, which you don't know exactly which function is. We have a list of possible types that this function can be receive as parameters of the being variadic, and we have the list of expressions, which is the variadic part of it. So what I don't know if I can say for certain, now that I think about it, is if we know that this list is containing uh, the same, all the expressions like end up having the same type, and it is one of those types here, can we say that we know the return type of this function? That's the question.
okay, so let's see. I have these, and I am receiving a specific type to apply to it. Let me.
Yeah,
Uh, so
that's
little
interesting.
messed up. Let's get like a F here
Man, I think the answer needs
and
to be yes, but
apply.
I'm not sure.
Needs to be.
Yeah, because I'm thinking
Oh
how
man,
can a function not
that's really naive.
return this? No, I'm not saying
It
it's
depends on the no. It depends on the way that you want. For instance, if you call these like, do you know like polymorphic like variants in Okama?
I'm not quite sure about the name, maybe the idea.
Um,
Yeah, but go on, just go.
but okay, let's say we have this type, like a function with this type, right? And then I'm applying to a type that is one of those, right?
Yeah.
And in this case, the function is just a simple identity.
Yeah.
So let me see. We might as well just return this type, right? I think it would be okay. But the question is regarding would I just
Oh,
say a
now I
specific type,
understand why you
one of
said
those?
ADTs is the way. Now I understand. Now
No, no, but
totally
we are
correct.
discussing here your solution, right?
Yeah.
But there is also the other point that your solution it's solving a problem that ADT already solved. If the problem is I want an argument that is a one type or the other, that's a fucking ADT. I don't know what we are discussing that.
No, but we are not only discussing that. Like
Uh,
we're not discussing a function that can have a sum type as the parameter. We're not discussing that. What we're
mm,
discussing is we have a list of arguments. We want to type check all of those arguments according to the function, according if the function receive can manipulate these types of arguments.
okay.
And then that's the problem that I started tackling before because this it seems to me to be the easier one, the easiest case possible.
Well, so what you just said really sounds really simple, and the solution is also really simple. It's literally you get the type of the argument and you see if it's equal to the parameter.
And
Like
if all of them are equal,
all of them are
if
equal.
all of these are equal.
It doesn't need to be the case.
Yeah, but if this doesn't need to be the case, we would be able to sum a rational number and an integer.
No, no, that's the thing. This case, are you talking about a variadic function?
Yeah, like sum or minus or
Then
multiplication.
yes, that's the case indeed.
Yeah, but I don't want that. I don't want to be able to sum an integers and a rational.
No, no, no. What I said was if you have only one argument and it is variadic, then you are right. Like all of those expressions need to be the same type.
Yeah, Exactly. So that's the thing. So that I started tackling this because it seems to me to be the easiest one. I don't know if it's the smartest one to start with, but it seems to be the easiest one to implement.
Yeah, but I don't think it's a problem. Like it's literally saying if two types are equal.
Yeah, so you basically do a fold on this to and you check if the final fold is the same type, like it is a integer or rational, and then you check if this is inside this, and then you're done. Then you're done. You're okay.
Yeah, I think the best way for you is to get the type that you want and just do the fold. Well, well, the fold, yes,
Yeah.
but it's like the predicate checking, right? It all of those are this one.
Yes,
Then you only
exactly.
do one round.
No, no, no. It's the opposite, I think.
Hmm?
Wait. Yeah, you
No,
don't.
no, you.
You wait. Let me explain first. I don't think you need to care in the beginning about this list. You only do this. You pick the first, for instance, integer, and you just check if everybody else is integer.
Wait, wait. It's because the situation that you described of a function that is variadic, you don't have a list of types of possible types.
Why not?
Well, because you don't. That's the thing we are talking about here. Like that's another problem.
No, wait. So we you didn't get the idea that I proposed, unfortunately. That
Mm,
sucks. Yeah, so I'm gonna try again with the fold in mind. So you're gonna do a fold here, just to discover, like the fold is gonna fail. Go, Magit.
I just have one question. Like some errors, sorry, like some types, like for example, numbers, we can get via the parser, right?
Yeah.
But how we are gonna, we need to propagate that when we assign to a variable, right? For example.
Yeah.
So a variable in this case wouldn't. I'm thinking here. Is still not set, by the way. I'm just thinking.
Yeah.
Oh man.
like just the
So
environment,
we need.
right?
Yeah, we need some sort of
Lemos, but I think I
environment
got your idea.
search.
Your idea is like I will do a sum, right? And then the type will be a special type that can either be one on the other, and I have like a special rule on the type check because I know that since it's a native function, I can do that special rule.
Yeah. Exactly.
So
Pretty
yeah,
much.
yeah, I think that works. Yes,
Yeah. Pretty
I
much.
thought I
But
thought you were talking regarding like general
no,
functions,
no,
like
that's totally a
defined
different
by the
conversation.
user.
Yeah, that's a totally
Yeah,
different conversation. But you do have a point about do after the native functions. I think that the best way to do it is to do the ADTs. Now that I think about it, I think you're correct. I think that the ADTs will solve all the problems.
like for which you, how can I say? For the case that which you say in native functions, ADTs don't work unless you already define the ADT in the environment.
Yeah,
And
yeah,
I
which is
think
not the
that's,
case.
yeah, what I think also would be a little dumb, right? Because you would need to like put the tags in the thing. Like,
Yeah,
why
that
would you?
yeah, yeah, exactly.
But yeah, I think it's a good approach for the native functions. For the normal ones,
Yeah, the
no,
normal
not a
ones.
chance.
Yeah, we need to discuss a different way of doing that. Okay, but
So
now
let
we
me
can help
think here.
Mageta. Uh,
Yeah,
s
so I'm still thinking. We need the environment, right? Because there's a
Mhm.
couple of things that we cannot infer unless we do well,
no, no, the
inference would be
environment
like
is actually we let's just go for a minute. So let's stop doing this, Mageta, and Nathan, just for a bit. Let's go to the prelude. I think that we need to add the types for the native functions here as well. Am I right?
Yeah, but man,
yeah.
we don't have anything yet.
No, but we can. No, we can already establish
Yeah,
the types, right?
let's think of the structure first. I think that
Yeah, like what is the type that you are assigning to if you don't know the types that you will have?
And there's a problem that I just noticed. If oh man,
if
Hmm?
every single time we change something in the structure, like in the prelude, like oh we're gonna add a new guy in the middle between the symbol and the JNative function comparison, whatever. Every
Where are
single time we
you?
I am in the prelude.url. Every single time we add a new thing in here, this will reverberate to the type checker and to the compiler.
Yes.
and that
Mm,
sucks.
what do you mean? Do you mean like that both type environment and values environment need to be in sync?
I mean that because we are using the same prelude for both the type checker and the compiler, every single time we do a modification in the prelude here, both of them needs to be fixed.
Wait, but they are like different environments. You
That's the
need
thing.
to
So
have,
two preludes then.
yeah, one
Nice,
for types.
nice. I'm
But yeah,
glad.
they need to be in sync.
Yeah, but they are completely different. So one they will not touch the other.
Sure.
That's
One
good.
is like values and other types.
Yeah.
Nice. Okay, go
One
on,
is the
Maggot.
annotations. No, go on. I'm thinking here, man.
Okay,
No,
so
but tell your problem.
So how do we start? Like I was thinking of making a function that will do sort of the same thing as the eval with because at that point we have the st, right? And then we just need to search things we don't have in the environment and look at the structures to see if they match with the things that are being passed in case of all.
yeah, but I
We have
think
let's
this
think of
should change to
the stuff we
type.
have.
That's literally what you
Yeah,
said, man.
dude,
That's
dude.
literally what said,
No,
Maggot.
but dude, wait, Lemus. Think of a second what we are gonna have in each case. So the first one is a literal, right?
Yeah,
So we are gonna have the type here.
yeah, we will.
So let's ignore this.
Wait, what? This is the expression, right?
Yeah.
Yeah.
So a
So what is
literal,
that? What is that here? Type.
well, it's the type. It's the integer.
Oh, okay. No, I forgot that like literal is like
Yeah.
Yeah.
a umbrella for a bunch of stuff.
Yeah. So this is the only case that we know exactly the. No, okay, okay. So this is the case that we already have the stuff. So we just return okay with the type.
Magetta, I have a question. I think
If the
that
names are the same, yes.
last session we tried to do this sort of pattern matching, and I remember it was not working.
Mhm.
Do you
Have
remember
we?
that?
I
I
don't. I remember
think
we tried doing with a list.
yeah, the list was part of it, but I think we also had a problem with. Let me check here. You,
But
you
if
guys can
it
go
doesn't
on there.
work, we are doing this everywhere, man.
No, no,
Like
no.
why it wouldn't, man?
No, no, no.
Yeah,
I'm not. I'm not saying we are not doing pattern matching. I'm talking specifically about this nested pattern matching thing.
Like
I
don't we
remember
have this
doing
on
this.
eval?
Yeah,
Let me just check here for a sec.
I have this in a bunch of places
I
actually.
remember we having a problem doing something related to that. But
Like
never mind, never mind.
we literally have here on line 10
Let's see.
like case, then, and else.
Case, then else.
Yeah, but this is not like a nested pattern matching. He says.
No,
Yeah.
but is
Oh,
like
but we have here
Oh,
line
okay. Oh, no,
26.
wait.
no, okay. So this. No, no, no.
Oh,
But this is
but
not the case. This is not the case because we are not
oh.
like putting a label to one of those values.
Why?
Like
But
Why
we are
we
pattern
couldn't?
matching okay. I don't know. I'm not saying we can't, man. I'm just having bad memories that we tried to do that last time and we were pissed and then we changed the approach. That's what
I
I
will.
remember.
I will just leave ignorant.
Okay.
If this fails, then it's your fault.
I think that's a good approach.
Okay. That's that. Thanks for that, bud. Okay, let's continue doing this here then. Uh,
Oops.
okay,
Let's see.
so the literal is the only one that we actually know something about it.
Yeah.
Uh,
So
Well, we know
not the
about
only one, right? We know an abstraction as well. Like we
well,
can
we
have.
know all of those. If not, the type
Yeah,
check is not
this.
working. But
Okay.
it's the simplest case.
Yeah,
we
I think he meant like a variable. You don't. You need to search, right?
yeah.
Yeah, I mean the sense that we will return something.
When you have an abstraction, you just pass an OK
Let's see. The
closure.
second one is a condition.
Yeah.
Yeah, Magita. Well, yeah, Lemos. We don't have closures here, man. Like
Yeah,
we have a
closures.
type for functions.
Yeah. No, I'm not. I don't know if I didn't add closures. Hold on.
Yeah, I just copy the thing.
Yeah, he just copy pasted.
Uh, so let's see conditions.
Yeah,
Mm,
conditions. I
mm,
think
mm.
it's easy. Like the case needs to be a boolean, and this needs to be equal to this.
Yeah, I
Makes
see.
sense, right?
But then I'm thinking here. Oh man. very. So we need to let me think, because that could be still an expression, right?
Yeah, totally.
Uh, but that expression needs to boils down to a bool. And where are we gonna check if that expression is already a bool?
Recursive call.
So we call recursively this type check, but what if it's not evaluated?
That's the
Like,
thing. We don't need to evaluate stuff to type check.
Yeah, you don't need to evaluate it.
okay, what I'm thinking of like inference. That's a whole other thing.
Oh yeah.
Like, we are always going to annotate stuff, right? So we don't have to care. Like, even if it's a random expression, like a function call, it needs to result into a type that we're gonna grab.
Yeah.
Yes,
I
but that
agree.
is important. That is an important detail, Magita. Like the whole point of us type checking doesn't matter if you are using like inference or not, is not to evaluate before everything is okay. So you never evaluate things
Yeah.
in the type checker unless you are using dependent types, because
Yeah.
then
Yeah.
you need to do
Yeah.
calculations for.
That's the case.
Okay, makes sense. So we type check this thing with the case.
Wait, you're gonna do all in here? It's gonna be terrible.
Who cares, man? Who cares?
Like I want to follow the same approach that we did with the eval because that was what make it readable. So
That's just
Like, as readable as you could, right?
it's just conversa para boi dormir. Okay.
okay, but let's talk about the closure. So we don't have closures in type checking. Does that make sense? I think
Closure is a
yes.
value.
Yeah, I think
Yes.
yes. So yeah, so we don't need closures in this case.
Closure is the bottom. Else here, and then we need to check
What about application, Anton?
type check.
Hmm? What is
Apply.
about it?
No, because this is the like the we're deciding mm, how we which cases we're gonna have for the type check function that you're gonna call recursively.
So yeah, so we check. Well, we have two things, right? Like a function and the argument. We check if the function is really of the type of a function, and if it is, we check if the arguments match with the parameters of the function. And if it matches, again, then we just return the what like the body of the function, right? The return type.
Oh, okay.
So there is no like type for application. He will just result in whatever the body is delivering if all the conditions are like matched.
Okay.
So the best way here would be just checking the case, right? And just evaluating. Never mind. Let's just evaluate everything. Fuck it. So we just need to now check case. Oops. How was it? I even forgot. Was it case off?
yeah, I think. Wait. Yeah, case off. Yeah,
Okay,
case
but
off.
we need to do something like Erlang. I think it was like
No,
type.
no Erlang, man. No Erlang, no Erlang.
Why not?
Yeah, just call. Oh, it's
Was it
because
like
you're not calling.
this?
It's not calling the function
This.
here. We are making labels and stuff now. Okay. Okay, no, you're
Be right
correct.
back.
You're correct,
Okay.
Magit.
The rabbit function there. So those two needs to be equal,
Yeah, if they
and
are
the
equal.
second, and this one needs to be a boolean.
Yeah,
So
if it's not a boolean, we just throw an error.
type case equals.
Wait, no, no, no. Okay, literal.
Oh, thank you. No, not literal, just
Yeah.
boolean. No literal, man. What the
Yes, a
fuck?
boolean is a literal.
No, no, man. This is the type.
Oh, sorry, you're correct. Boolean. Okay.
And then I think it's off. I don't remind
And
myself.
we need to close this also.
And then I think we can just check, right? If it's true. Oops. I'm mistyping everything. If it's
No, no, no.
true,
But
oh,
you have to do the
pattern match.
tuple. Yeah.
Yeah. If it is true, oh man, what the fuck? I feel like a Greg typing.
if it's
Not literally.
true.
I feel like a Greg
Oh, but wait.
typing
But
literally.
there's a better way of doing
Oh,
this. There's a better way of doing this. I think that we need to if we do true here. okay, just true, false, actually.
Oh, yeah, I see, I see.
Then we do, I don't know,
Yeah,
error.
the error is on the case, right?
No,
Yeah,
this
but
is
we
also
should
incorrect.
actually we should accumulate the errors, right?
Yeah, but we're not gonna do that because we didn't do in
Back.
the compiler. So
Oh, man.
if we have a false,
Yeah, the correct way would be accumulating.
yeah.
Because, dude, imagine like type checking a program, like compiling and not seeing all the errors of everything. That's how.
Okay, so this will be also an error, and oops,
I think it's Erlang
and then if
error reason.
this is true, no, actually this can be also an out card, and then we just say this is an okay.
Uh, Wait, why don't we
But
use the and
Oh no,
operator
just
instead of the comma?
yeah, I was thinking about it. Both need to be true, right?
both need to be true.
Yeah, but why more? I think I was thinking of like handling each
No, no, no,
case
no,
and
no, no.
accumulating the
No, it's not
errors.
good to do an end because then we can throw
No.
different errors for different. For if we
Yeah.
have not a boolean here, we throw a different error if the else and then are different.
Oh, yes, yes.
Yeah. So this should be, I don't know, type, whoa, type,
I
then.
sense we are gonna do a terrible like
That's it.
messages, like error messages. They're gonna be like
Mm,
closure levels.
you
Closure
think
level.
so?
Branches don't type check, and this is
Oh
condition
man,
is
you
not a
don't you're
boolean.
not getting the .NET feelings here. It should be something like
Man, we always
branches
complain
do
about
not
that.
conform with the
Holy fuck.
expected type.
Oh, I love the expected. Yeah. But Lemus, what we can do is, it is generic type, right? The then and the else branch, they just happen to like need to be the same. So what we can do is assume that the correct one is the first one because it's the only assumption that we can do.
Oh yeah.
So you just say, oh, the like else branch didn't match it with this branch here that has this type, right? So expected int but got in string.
Okay, so else branch does not conform
We could even split the type here.
Conform.
We could
with
even
the
split the type like first branch type then, second branch type else. I think it's like better for readability.
with
Yeah, like just formatting the types.
expected type of branch then. Okay.
Yeah, but then like
No, we're gonna add the types. We're
yeah,
gonna add the
okay,
types.
okay.
So okay, can is this correct? This?
It seems like. Uh, mm, what if it's okay? Yeah, seems right.
Okay, so now let's add the
Uh,
I already forgot how to do that. It's like tilde p or something like that.
just something. We're not checking if it is true, right? Why
Hmm?
just the type then? Okay, because just one of them. If they're the same, then doesn't matter.
Yes.
Okay.
So condition is not a boolean.
Yeah, but one thing, I think that is already okay, so we don't need this.
Oh, that's true. That's true. I forgot. That's true.
And you need
Okay,
comma here,
so
comma.
condition must be a
Oh,
boolean,
here. And
a boolean, and found tilde this. Uh,
then
oh,
I think it's a list.
yeah, but it sucks because we need to get rid of the OKs now.
What? Oh, I
Okay,
mean
let's better match in here. What
Why
about
do
that?
we have those OKs, man?
we can do this. Like we can do three, like here, like
Now
these
that is a
ones.
point. If we're not gonna do error accumulation, why we need the
Yeah,
OKs?
yeah, fuck it. I mean, we should do error accumulation, right?
We should. We definitely should. So I don't
Yeah, but that's
know.
easy to fix later. Yeah, no, who cares?
Okay then. So
Like I think that the case for like, can I say? that kind of monadic treatment is either because you want to have guarantees at the type checking, but we don't have type checking.
I don't think that's how it works, man. The
Hmm.
Erlang error formatting.
Oh, it's not the same as the IOF, right?
Args, yeah, you need to pass. Okay, there's a function that has two args that accepts args, but it needs to be a list. So
Oh, yeah, puts that in there. Uh, else branch this of type this does not conform with the expected type this of branch then. And then this, and then we're gonna put type else and type then. Okay, okay,
okay,
it's not
looking
that
good.
bad.
Okay, so this is the condition. So we can call it here. Oh, it's already called. Never mind.
By the way,
Okay.
I have a question, Nathan. Because we are changing the this, does that mean that you're gonna have to do like two parses at the same time?
I don't know what you are talking about,
Mm.
but you don't need two parsers. Oh, but you could, but you don't need.
Oh, we're gonna use just one parser
We
for. Wait.
didn't get what you mean to basically type stuff. Is that it?
No, no, I'm
To
just
get the
confirm.
types from the
Yeah,
syntax,
I'm just confirming that we are
we
using the same AST for both types and values.
Yeah, I was assuming that.
for types and
Yeah,
And
the
the
AST is containing the
expression.
both types of information. It's
well,
containing the type and it's containing the value.
well we don't have values.
Not in this
Yeah,
phase, but
man.
we're gonna use it in here, in the spoon.
Like, okay, the parser will result in a AST.
Yeah.
It will include the expressions, and in one expression in particular, the abstraction, it will have types there, la,
Oh.
and we will parse them.
Okay, just to confirm that we are, because I started, I don't know, just imagining, man, are we changing the ST just to make be more convenient? No, okay. Okay.
No convenience here.
Depends
No
on what
convenience.
you mean. Like, if we have an AST here, we would be like adding a type into it, right?
Yeah. Environment, abstraction.
Oh, let me remove this crap. So, oh man, the application will be slightly.
Meh.
We need to do the abstraction first. Let's do the abstraction.
Do we have abstraction? Isn't that the closure one?
I think that the application is the not so easy one.
Really?
Yeah.
The application you just get the header
Hmm.
and you match with the arguments. Like that doesn't seem to be that
Yeah,
hard.
the abstraction you just put in the environment and get the body.
Let me see.
Not saying hard, it's hard, it's harder.
Let's
The
do the abstraction first.
abstraction, but in the environment, and you get the but I'm not sure I got the abstraction part.
No, let's just copy paste and then we can go
Okay.
from there.
Okay, so like, what's the type of abstraction, right? It's the parameters and and the return, right?
Yeah.
So how do we know the return?
You need to type check the body, passing the parameters.
Yeah, that's the thing. Passing the parameters is like putting them in the environment, right? Because if the body has X, that is your parameter, you only know that
Yeah.
if
Because
you
of the
inject it.
environment. Yeah, makes sense.
Yeah, so you pick the parameters, you put that into the environment, and then you type check the body. Is that correct?
Yep.
Yeah,
Yeah.
seems okay. So type check.
Let's watch Lemos doing stuff.
Man, Lemos programming Erlang.
This is so
What
this is
the
so
fuck?
funny.
I don't know what you guys are laughing, man, but okay.
I also not really sure. Like rationally, I don't know why.
It's
But when
funny.
Mageta is doing like Lisp or Erlang, I mean like okay, Mageta. But
Okay, it's so stupid. Okay, it's autistic. I can
no,
explain.
no, like you know the shit, right? But then Lemos is doing. I'm like, what the fuck?
I still don't understand, but okay. Still don't understand. That's fine, I
It's because
guess.
Mageta he knew already the shit, right? Like
I
Lisp
didn't.
and Erlang.
No, Erlang, I didn't, man.
You kind of did, man.
You
Like
kind of
you did
did.
something before.
Yeah.
Uh,
Uh,
did I?
You showed me doing stuff.
Oh yeah, yeah. Okay, I was learning as well. Like when I was doing the thing. Oh, we did the first draft.
yeah.
The lambda call.
Yeah, okay, so type check abstraction, how this needs to go. We need to put this into the environment. It's basically copy and pasting then the other
The
one.
yeah, the other one.
Where is the vol? Wait. The vol abstraction calls. Wait, we're gonna have to change this because in the
Hmm.
order in the evaluation we were making a closure.
What?
And then yeah.
Mm, Mageta, we have a point here, man. Um, how can I say? Like you see here on the type check on the literal.
Yeah.
So you have like what's the name? Like a symbol for the name of
Hmm.
what literal is, and this is the content, right?
Yeah.
Yeah.
But not all of them have content, so we need to pay attention to either put new
Oh right.
or
Yeah.
to match another case.
Yeah.
That's
Hmm.
true. Yeah, but okay,
Yeah.
can you guys help me here? I think when
Let me see where
because in
you
the
are.
in here we are using creating a closure out of the abstraction, but we need to do something completely different then.
Wait, where are you?
Oh, here, line
Spoon.
13 of the spoon.
Yeah,
What? Why on spoon?
because this is our like
You
baseline
don't need to
basically.
compare, though. I don't think it helps that much to
No,
compare with the
we are
evaluation.
comparing because we know that in some point in here we are
Exatamente.
adding to the environment the thing.
Oh, you want to know how to add into a map?
Yeah, no, we don't have to know. We did. We just forgot.
No, I know how to add stuff to the map, but
Yeah, but like, is
what
that?
to add to the map? That's my
We
question.
need to add the parameters to the environment, don't we?
Yeah. So the first thing that we need to do
Okay,
is
we
to
did it here.
check. Wait, I forgot what's the comment, but it will break just for a while.
I forgot how to comment.
Oh, man.
Uh, so
Oh no. That's so great, man.
so
Okay,
you
there
need
is
to
one.
check if the labels don't repeat, right? Because I guess that's dumb.
Wait, what do you mean by labels repeating? You mean like XX?
Yeah.
Oh, okay. Wait, is the type checker the one that would supposedly be doing that checking? Like repetition?
Wow. Yeah, because
Yeah, on the parser you would just parse normally. Don't check.
Oh, okay, so it needs to
oh,
be
there are
this.
a lot of advantages in like accepting like a more general syntax in our parser, but reject at the type checker.
Oh yeah, I didn't know
Like,
that.
yeah, like for you to do some things like metaprogramming, right?
Mm.
Then your extension for metaprogramming can run before the type checker. So
Ah,
you can accept
Hmm.
invalid syntax, do transformation to a valid one, and then it
Yeah.
will type check just fine.
Yeah, that's what I was going to say. We found macro expansion as well.
That's
mm.
really good, man. You could do like crazy stuff with extensions that you cannot do in the language.
Okay, okay, okay. So we're gonna
We
check the
just need
labels if
to
they don't
watch
repeat.
out. We just need to watch out to make peer like non-mutable macros, like to not allow that because if we do that, we can't make the LSP later
Mm.
I didn't know
because
that. That's
because
interesting.
you're gonna fall into an infinite evaluation if you just like uh, because the LSP tries to type check and like tries to use the compiler services, right?
Yeah.
But then you haven't checked the evaluation of a macro yet. So you need to
Evaluation of
expand.
the model.
But then if you have a non-hygienic macro like that does like a bunch of mutability shit,
Hmm.
then you have no guarantee that things are gonna be right. So
Hey, Mageta, but what you are saying doesn't restrict to mutability, I guess. I guess that any kind of stuff that do you have like a typing checking that is undecidable, it will lead to this
Yeah,
shit.
Yeah, okay, so let's continue doing the.
So other type parameters to the environment.
I know that Clojure it supports LSP because they nuked the mutability out of macros. That was what I was talking to Commander.
Type check. What I think is really smart because man, you shouldn't allow any kind of shit in the macros, especially for other type system. But in Clojure, they don't, right?
Mm-hmm.
Add a type parameter to the new environment with the name. Makes sense. Type check the body using the new env. Yeah, that's pretty much what
Oh
we need to do.
wait, we are forgetting about something, aren't we? We need a notation regarding what is variadic. Huh.
No, no, no. It's not here that we check that. It's the It
No,
was
no,
the
we
closure
do
that did
need.
that.
No, no, we do need to check, man. We need to check everything before run. So the eval is checking stuff, but the type check will check also.
No, no, no. I'm
We
not
could
saying that.
even.
No, no. Wait. I'm not saying the type checker will not check that. I'm saying that maybe it's not in this function type check abstraction.
No, no. What I'm saying is that how can I say? Uh, so you have a notation on the expression if it is variadic or not, right?
Yeah,
Some like syntax clue that the
yeah,
parser will get and will return to that expression.
yeah.
When we are type that, that clue must be on this type of the function also, so we can check the application
Wait. Yeah, but wouldn't that be inside the body anyway?
inside the body.
Yeah, let's suppose that inside the body we have a native function, for instance.
No,
So,
no, wait. Variadic we're talking about. So it's on the parameters. You need to tell which parameter. Well, if the function has variadical arguments, right? Because we know that is
oh,
only
no, no, no,
one,
but that's you're
and we
talking
know
about
that is on the
user-defined functions.
user-defined
Yeah, I was
function.
just thinking about native ones.
Well, the native one, you also need to put on the environment there that the parameter has this type, because the type for function is the same for native functions and normal ones. It's the same type.
Now, can you go at spoon here?
Spoon?
Yeah, spoon dot
Why
arrow.
can't where can I follow you?
You
Just
can
go.
click on his name.
Yeah, clicking on the live share tab, you have the options of clicking on the names.
Oh, okay.
Yeah, so you can see here that in the eval application is the one that we are doing the eval closure, which has the annotation if it's variadic or not, and then
Hmm.
we are pattern matching it in here later, right? Like here. But this is in the all of this is happening in the eval application. What I was saying is that I don't know if we should check for that in the abstraction checking.
No, no, I'm not saying regarding checking. I'm saying in the sense that the expression we have this annotation, and we will just pass this annotation to the type of the function. We are
Oh,
not comparing things against
oh,
each
we need
other.
to pass
The
that
application
also.
will do that.
Yeah, that makes sense. We need to remember to do that then. We need to add the variadic information alongside the type.
We don't have type checking. We need to remember everything.
Okay. Okay, so let's do this then, Mageta.
Okay.
We need to do parameters is a list as far as I
I
remember.
look at Erlang and I get like lazy. I don't know.
That's understandable, Magita.
No, that's really weird because he was so excited when like we did.
Yeah, but dude, the language is like there are some languages that like you start to learn and you don't stop learning. Like for example, F sharp, OCaml, SML. Like you start learning the language and there is a point that you get really good, right? But there's still something like that you can do that is different with the syntax, or you can do stuff around. Here, I feel maybe it's our limitation that we don't know the language that well. But man, like I have a feeling I'm always doing the same shit all over again.
Magita, that really sounds like bullshit, man. Like
Oh man, it's
because
total
I
valid
think
feeling. And
like the feeling is I'm not saying it's correct because man, it sounds like a thing that oh, that's the comment. So I think that this depends more on the person. And you know, man, like even if you get the simplest language, you can always like be more of a Jedi in it. But
I'm not sure, man. Like Go, for example, you only have one way to do the thing, and that's partially good. That's debatable.
Oh, you're gonna see this one
uh,
single time ever, folks.
No,
Just for
no.
the recording, Mageta is
Oh man.
saying something good about Go.
well, he
But
didn't
dude,
say it was good.
The
He
the
just
yes,
the
stated.
world the no, he said it's kind of good. He said it's
Oh,
recorded.
it's kind.
kind
Okay,
He
of.
said it,
okay, I see.
and the world will end tomorrow because of it. So
But
let's.
isn't that like Python, Magita, that you can do in the Pythonic
No,
way, like
don't
on?
try, don't try, don't try.
We almost got him.
Stop.
Almost
Alright.
there.
So let's do this crap. So check if the labels do not repeat. Add the type parameter to the environment with the parameter name. Okay. And then type check the body using the new environment.
You know what sucks? I don't think we have a way to do the first step in like a known mail way. I'm reading the functions used
A
for
mad
labels,
Yes.
way.
and all of them are all like don't
Don't you
have
have
What
like unique?
what is the parameter, by the way? What is that? Is it with this?
parameter. I don't remember anymore, but we can check this in evolve. So the parameter, yeah, it is two things: a tag saying if it is variadic or not, and a
And
bunch
the
of
labels.
labels,
And the labels now they need to be
unique.
label and the type, right?
Yeah,
And unique.
and we need to also take care of passing the variadic
Oh
information
no.
over.
Dude, we're gonna have to redo all of our pattern matching.
What do you mean?
Like here.
What?
Uh,
I'm not following you, so wait a second. Oh, here.
Yes, we're gonna have to redo all the pattern matching to adapt to the labels. Where are we using the labels? Let's see.
Wait, what do you mean?
Oh, we are very lucky. Yeah, we don't. Okay. Oh man, thank you. Because if we add one thing here, like I was thinking, oh man, if we're pattern matching like anything inside, then we're gonna have to do like a bunch of like fixes. But apparently, like we don't use the labels, right? We check for
Arguments.
it's fine.
Wait, arguments. Yeah, parameters. It is a top. It is a tuple of a variadic tag and a list of labels. Yeah.
So okay, so let's do this here already. So this don't care if it's variadic,
No,
right?
no, no. We care. That's the thing. Variadic info.
uh,
Do
wait.
we?
We need to pass this on. I was talking to Nathan was just saying this.
I don't see why.
We need to type check this because if a function is variadic, or the opposite, a function is not variadic, but we are passing a variadic set of parameters, the type checker should say, I don't know how the message is going to be, but it should say that that's not cool, that's not correct.
That's not cool.
Yeah,
Hey, bro, not cool.
not
Oh,
cool.
okay. I see. But actually, it would be better checking. But
Oh.
should we check if it's variadic or the amount of parameters you're sending?
uh,
That's a check that we should have done here.
Wait. What is the thing, Mageta?
Like we are checking on the eval if the amount of parameters that you're passing to a function match with the header, right?
Hmm.
Shouldn't
Yeah,
we
we
do
need we
that
need to
here?
check that. Yeah. You could literally delete this from the eval now.
Yeah. So should we copy the code there?
I
wait,
I don't
guess
want to do
so.
wait.
that.
I didn't get what Magetta said. Magetta,
Like we're evaluating. Think of the what is the eval? That's
man,
like the
where
our
the heck are
runtime.
you? Oh, wait, you're here. Okay.
And here, like our eval is like the runtime, right?
Yeah,
Think about this.
yeah,
We are literally evaluating only if the thing like conforms with the header of a function. Like let's say, uh, you have a function add that receives a and b,
yeah,
and then like you try to do is add 1, 2, 3, 4.
yeah.
That's wrong.
That's wrong.
But they will pass through the type checking, and they will only be available on the because notice this is not variadic. Like I may set the flag variadic not here.
Yeah, yeah. The for ariarity 4, right?
Yes, but the arity is totally wrong. So we should check for the arity here, not in the evaluation. Because, well, when you try running the actually
No, that
give
makes a
you
ton
the.
of sense. That makes a ton of sense. But then there's
Magenta.
a problem that Nathan said 2 sessions ago, which is that we don't have the arity information alongside the function in the AST.
Hmm?
Yeah, we don't have that
No,
info.
dude, it's the same shit we're doing on the eval, but instead of doing there, we do it here.
Wait.
Like, here.
Magenta, like the only good thing about being dynamic is that when we know that the thing doesn't happen, we don't need to check it, and we are not doing that yet.
Yet.
Oh, I see. Is this if like length arguments is
Yeah,
greater than, and then we made an assumption that if it's greater, it means that we have some arity and the remaining ones are just variadic, like inside
yes.
the rest. Yeah, I
Mm-hmm.
remember now. I remember now.
And Lemus, like the expressions will remain the same, right? Like
Yeah,
we will not like the expression that is be handled should the type check will be the same handled to the evaluator, right?
yeah.
So we still have the information not to check anymore because the type check did it, but at least to
Oh,
know
that's cool. So
where
we're
we
gonna
get like the part of the list, right?
yeah, we're gonna be able to remove from the evaluator later then.
Yeah,
That's
we
cool.
don't need like the we
That's
don't
cool.
have type check in Scream at the.
Okay, let's just copy paste all of this then. Why not?
Oh,
Wait a
hey,
second,
that will be hard to.
but wait a second.
Okay.
We are evaluating stuff, so we cannot just
No, we're
plainly
gonna
copy.
replace this for a type check.
It's not like one-to-one
No,
transformation.
it's no, definitely not. But I'm saying that it's not that it doesn't seem that hard to me. It's just copy paste in every single place we are. The first step is every single place we are evaluating, we're gonna change that to type check. That's it.
Yeah, okay, here I can see that.
But yeah, this is on the application. Are we doing the application already?
Yeah, actually this is the
Did we
no, this
finish
is the
the
abstraction. This is the
abstraction?
abstraction. Yeah. Yeah,
Oh
the
yeah, we
abstraction we
didn't.
don't care. Let's ignore that on the abstraction.
Oh wait. Oh, okay, we're just gonna pass through to the application later then.
Yeah, the application
Okay.
is just
Yeah.
but what do we need to type check? The abstraction.
We need
We
to
don't.
we need to make
Like
sure
only
that
the body,
we
right?
don't have labels that repeat.
Yeah, we just check the body if it has the same, right? The same type as the annotation. Let me see. Add the type
No,
parameter to
no.
the
We
end
don't
with
have
the
to check against
body.
anything.
Type check the body using the new environment with
Yeah.
the things in the parameters. Okay.
Yeah. So that's the thing that sucks because to do this first step, which is to check the labels don't
Uh,
repeat, we
no,
don't have
no.
any unique function.
We do. I just sent it on the
Oh, we do.
Discord.
Do we?
It's their language. It's a fucking good language. What do you mean?
Oh,
The
there's
bats.
duplicate.
Man,
The bats.
if I was editing this video for real instead of just exporting directly, I would literally like cut the like 5 minutes ago when Nata was
We should
and
make
put
like
it
YouTube.
right
We
here.
should make like YouTube shorts and
Don't
short
give him the
videos.
idea, man.
All right,
Uh,
so let's go, man.
oh, okay, this is not that bad. We just do an if. Nice.
Yeah.
It is not that bad.
Yeah, so if already forgot how to do an if.
Wait. Unique doesn't return for you a, a boolean.
No,
It
I don't want a
makes the
boolean. I
list
No.
don't know.
unique, right?
I don't need a boolean. I don't need a boolean. Nata.
Are you checking the length then?
No, I'm just gonna check the lists themselves.
Huh?
Yeah, I'm gonna pick the list of labels, which is here. Apply unique and then compare that result to labels. If they're not equal,
Oh, if they're the same,
done.
yeah. Okay, I get it. Yeah, that's okay. That's actually.
Erlang. I already forgot how we do this. Erlang.
Yeah, but wait, is that
But
from? No,
man,
no,
just check
there's
the
just this.
length.
No,
Like
but no, but
you
dude,
don't need
like
to
the
do the
length.
equals, right?
That's this kind of the same ish. You're gonna check the length of the unique with
Oh,
the
but
length
wait,
of the
for
labels.
no, but wait, there's
It's
a
just
difference
that
because
there
if
is
it's
less
equal,
comparisons.
but if it's equal, you need to sort first because
You
there could be all
don't.
displaced. You know.
No, I don't think you don't because they are the same input. And if nothing was removed, They are all in the same place. Unless unique changes the order of something, that would be really
No, I
funny.
think wait. Let me check this in here.
Don't trust Erlang, man. Don't do that.
Okay, so returns a list containing the elements of the list with duplicated elements removed, preserving the order of the elements.
Okay.
Whoa.
Okay.
Whoa, that's plus one to Erlang. Holy jeez.
Oh, I think it's actually more stupid to do that. It's like I would be really surprised if they actually need to do that.
Do we have length? I already forgot. Do you have
Yes,
length?
length. Yeah, just use length.
Where is? But do we have that function?
Damn man, dude.
Are you
Hey,
sure?
Length.
Mageta. Don't you have a function that to return like the unique part and the length of it?
I
Like
don't know, man.
like that match that you do the two things at
Oh
the same
no,
time?
no, no. That's cursed. How?
Length and
What is the
unique.
unique? What is the unique function?
It's like this.
Oh, just unique.
They didn't add space to the U and the E.
What the fuck? It's on Erlang.
Yeah, Erlang lists, and then we have unique.
Wait, it's on lists then.
Oh, which by the way, there is a version of
There's
the
no
unique.
unique here
Oh, that's a
on
problem.
the lists. Like unless this exists, which I don't think it does.
Like on the documentation at least, it's under
And it
lists.
is the same documentation that we were using before.
Well, let's assume it's working and the ISP is broken. So it's unique like this, right?
Yeah.
And then you just pass two things.
No, yeah,
No,
not
one
two
thing.
things,
One
one
thing.
thing, and then we're gonna do any like comparison with this with the length.
Oh
Okay,
wait,
okay,
the
okay.
labels are not just strings, right?
No, they are not just
No,
strings.
So
no.
maybe you need the function to map it. So unique to, right?
Yeah, there is a version of unique too. But why don't we? Why does that matter? Why
Because
having?
it's
Yeah, I don't know.
yeah,
Really.
because it's faster. Because otherwise you would need to run through
It's
labels
faster.
to
So
do a map.
are you really? Okay, you are fair.
Well, it's
That's
also
fair.
easier, man. Like it's less syntax or also.
Okay, that's kind of fair. So there is a version of unique Namageta that actually receives two parameters, which is the
Mm-hmm.
function of comparison and the list itself.
Oh,
Okay.
it's a comparison.
I'm
Oh,
not. No, it's not. I don't know if
wait. Return the list contain the elements of list one without the elements.
for which fun return
Wait,
duplicate
I'm not
values.
understanding that. Can you guys take a look? I thought it was a map, but if it is not, then you're screwed.
Oh, it is. It is the function of comparison to determine the duplicates. Yeah,
Oh, that sucks. That
yeah.
sucks a lot.
This is basically no. That's exactly what we
Ah,
want.
No.
Yeah, it
What we
is.
wanted is a map. Oh, okay, yeah. Oh, okay. It also works. Yes.
So a parameter is
I don't
composed
have
of
the
how many
browser.
things?
Who cares?
Wait, it does.
The labels are composed of labels are just strings. No, labels are just strings, Nathan.
R?
Yeah.
Don't we have like?
No,
Dude, we have
labels.
the REPL here, man. What are we doing?
Wait, we have the types, man.
No, do we have the types? Wait.
Yeah, isn't like a list of tuples of the name and the type?
So this function doesn't exist. Unique.
Wait, am I reading this correctly? Yeah, unique.
Dude,
UNIQ.
is that? Are you sure that's on lists?
Man,
Man,
yeah.
open the link. Just go to open the chat and click on the
I
link.
don't wanna open because that's gonna record probably. If you're sharing my screen, I don't know if you are.
I am
Oh,
sharing.
you are sharing hold, right?
Yeah,
Oh,
the code of the thing.
oh
Okay.
yeah, yeah. I see.
No, but even if you're just sharing the VS Code, just open and just check for yourself to see
No,
that.
like it's the opposite. He's sharing everything, right?
Yeah.
Oh, but I'm not showing your screen, Market.
Let me share just. Yeah, okay. I'll just share Visual Studio. Let's see.
But I want to I want to confirm what Nathan asked. He asked if we have only strings or labels. I think we only have strings, man. Just a sec.
And where are the types?
That's a good question.
Well, they should be there.
I think they
Oh
are in
yeah,
the arguments.
dude. We don't. Yeah,
The
we don't do that.
arguments?
Yeah.
What do you
Oh,
mean?
wait. That's in the OTP 24.
Oh,
The
that
type.
sucks.
We are using OTP 24. I think I can replace it on Nixus. Let me see.
I literally hate this language, man.
Yeah, I'm not very fond of it. I
But
thought that would
that's
be.
just version problems, Nathan.
It's. I think it evokes a condition in the mind
No,
actually.
but there's a bunch of languages that even the ones that we think are kind of okay, they also have version problems. So
Yeah, but I don't think they will like await 24 versions to add something like a unique function, you know.
man,
Well, if that was the case, right?
what the wait?
But well, we need types on the parameter language.
Yeah, that's what I'm checking here. Oh no, we do. Okay, I'm not. Okay, that
Wait, where are you checking?
spoon. In
Wait, let me
localhost
follow you.
here.
Yeah, but when you wrote that, we didn't have types, right?
No, we
So
did.
what?
Yeah, we did.
How? It was a typeless language. We didn't have type check. What do you mean?
No, it was not a typed language because we were we were typing with tags.
But you are saying that, ah, man, like
It's here.
if on the abstraction, okay, where is the thing that you say is a type
Yeah,
here?
so this is an argument, which is a tag, and
Hmm.
this should have a literal, as far as I remember, or something like that.
This should have a literal. This is on eval closure, man. You are not you.
Oh please.
Oh
We're
no,
going
this is a
local.
string. This is a string because we
No,
are
no,
transforming this to a map. Yeah, this is a string. We don't have the type in the parameters.
yeah.
Oh no.
No, but I don't know what you are saying. It's just literally you treat as if there is because the parser will return it.
What the heck, man? Why is it not replacing? I
Oh,
literally
it's oh. So you
specified.
mean that the parameters don't have because oh, of course we don't. We don't. We just have types to evaluate in runtime, right? With the
Yeah, yeah.
literals.
I'm not sure if you can call them types, but yeah.
Yeah, just a bunch of tags. Yeah, so we don't have, but we have kind of to assume that we have. Oh no. Oh no.
As in any dynamic language. That's so good.
Why don't you just do a dynamic link?
Well, we kind of did. We are like killing him.
Yeah, that's what I'm
Killing.
saying.
How can I say that?
Killing the
Killing it.
dynamism. The dynamism.
Healing it. Okay. Okay, so let's make
Okay,
the
core
function now.
dumped. Core dumped. Cool.
Oh, but that's wild, my kid. You're doing some true hacking there to get the unique for us,
Oh
man.
no.
I appreciate that.
I just gave up, by the way.
Okay, so oh wait, so did you fix it?
No.
No. Oh,
No.
nice.
We need to write a unique function.
No.
Wait, can't we pick the source code? Is it done in Erlang, the thing?
That's a good
Well,
question.
if it's done in like I don't know Java.
Oh man,
Oh
no.
wait, no, wait. We are using OTP 24, you said?
Yeah.
Oh, this is OTP 25. Can't we
Oh.
just upgrade it?
Yes, I tried, but then we need to replace like rebar or the LSP everything, and the for some reason it's giving me a core dump.
But isn't that the point to be easy on Nix? Like only change
No,
the
it
files
is, but
and
dude, the problem is I need to find the other packages. I'm not gonna do this now, man. Let's just do.
oh, okay. It's not just changing the number, right?
Yeah, I need to find what are the numbers.
How you do equal? I already forgot.
It's the rabbit.
The rabbit.
Rabbit. Yeah,
Isn't the
rabbit
rabbit the
operator.
different?
No, this is the rabbit operator. This is equal.
Oh,
Okay.
rabbit. Oh, because of the whiskers, right? Oh, well, it
Uh,
could be a cat, right?
Oh, here it comes. Lobby.
labels, I guess.
Not as if I'm biased toward cats or something.
Oh no, absolutely not.
Oh,
No, wait. We don't need this here, I guess, right? We just pick the labels. We check the unique ones. Oh, we need because we need to determine how we're gonna classify the duplicates. That's correct. Okay.
Magetta, Lemos is hallucinating. He's using the unique man as if we
As if
have
it
it.
existed.
No, we're gonna have to implement it somehow.
Or we just go through Stack Overflow and find it.
That's actually not a bad plan. So.
Oh, do you have list equal?
Oh wait.
Oh.
Oh wait a second. We have usort, which is unique sort. You're sorting and
What?
removing.
No, you are kidding me.
How can we change the OTP version of this thing,
Dude,
man?
why don't we do a removing fun? Let's do our own, man. Fuck it. I give up.
That sounds like a half an hour to.
No. That's I'm gonna use my prologue.
Ooh, prologue skills.
Yeah.
How can we
So
change the version of the
so let's
of
see. The
OTP?
base case is this, and then we just return it because well, see, unique on the case that we have a head and a tail. So X and XS.
Oh,
And
here.
then we have this, I think. We can split a list and we can construct stuff inside. So in Prolog, you can do the head and then compose with the tail. And then we can
Wait,
just see how
but you
is
are implementing prologue to help you with what is the algorithm?
yeah. Oh, here or
Man, but that's a bit
yeah.
tricky because, for instance, I guess you need like a hash map, and but that will not appear in prologue, right?
Wait, just a second.
Oh
Because
man.
wait,
We
this
don't have
needs
a
to
equal
be
function,
wait. We do.
do we?
Yes, we
For
do.
lists?
Yes, we do.
Where?
Hang on.
That would solve the
Okay,
problem.
how
I
bad
think we can do this.
would it be the fact that I
And
found
then
in GitHub the
unique.
implementation of unique?
Shut up. Shut up.
Just
And
spaces,
then
Lemos.
no.
Magneto.
I'm finishing. I'm finishing.
It's not that
Oh
long
man.
actually. It's not that long.
This.
Send on the chat, man.
How is
Let
the
me see it.
difference? How is different? I think we
Um,
can do Erlang.
the different
Oh,
is
Oh.
the implementation is not using
is
comparisons.
What is
is
the
this?
difference between those ones, Mageta?
I
Like
don't
the one
know.
that.
I think it's this.
Oh man.
This. And then it needs to be between
Wait,
the
but
thing
don't the description is telling you the thing?
and it's not showing a Visual Studio for some reason.
Oh fuck.
And this. Okay, I think that's it. Wait, there's something wrong,
Okay, so
which
this
is
is the code, not
Hmm.
the GitHub
something.
one.
When is list? Oh fuck, they have to check for the type.
How's the Orman? Erlang. Oh, what the fuck?
Accumulator.
How's the or?
I think it's double pipes, don't? Oh no, it's or. Yeah, it is or indeed. No, it is
This?
or. No, it is or. Or written like in English. It
Wait.
appeared. It appeared when you did the
No,
VS Code one.
wait. That's compatible. It works. Okay. But this is not or then.
This is
It's
not
not a
or.
thing.
It is Erlang with column or, man.
No, dude, what is this?
I don't know.
Oh, hey, that's a really bad implementation, isn't it? Look at the list member.
Oh no. I didn't classify how bad or how good it is.
Wait, isn't that the standard library?
No, this is a GitHub proposal.
Oh, okay.
No, not that. It just put Erlang column or like
I
or
think
the
this is
word.
just concatenating. Yeah, which makes sense. Which is what I. Because it could be or here, but I don't think it handles or. So this is the concat. Or concatenating? I don't know.
No, but do you want this to be concatenating or or?
Yes, both. It doesn't matter. Like both
Oh,
should work.
Holy.
If or doesn't reply, like I don't know, a boo in this case. Like I
or
mean
or
bitwise.
No,
concat.
let's check. If this works, you have
No, like
a good proposal of a
no,
MR for
like
Erlang.
I mean no, dude. I mean like F sharp, like that you can do with two different numbers, like enums or something like this, and then you just get the both of them. So it's like a concatenation as well.
Um,
Let's see.
I'm excited.
Uh,
Let's see.
really?
Yeah, man, 2 lines. That's not that bad.
Yeah, dude, this is
Wait, but is
functional.
that valid Erlang?
I have no
No, but
idea.
it's not complaining. This and this syntax error before.
The first arrow. The first arrow to the right.
Why the first error?
Interesting.
It's not complaining here. Oh, could it be that shadowing doesn't work? Oh man, if that doesn't work here, that's so crappy.
I work in the repo, right? Yeah, that's okay.
Oh man, no, please.
Magneto, that is somewhere there that you are checking if the new one it's present on the already unique list that you have.
Wait, say it
Like
again?
you have assumption that you have a already unique list, right?
Yeah.
So the new ones that you are iterating over, like the head, are you
Hmm.
checking if those are included in that already unique?
If I'm checking if those are already included in.
Like to guarantee that is really unique, the new one, you cannot just compare with like one thing, right? You need to compare with the whole already unique
Oh
list.
yeah, that makes sense. Yeah, yeah. Or if the list were sorted, that would not be necessary, I think,
Yeah.
or something along those lines.
Ah, man, let's just do this. Okay, paste the thing.
Oh,
Oh man, I was so excited. That's bad. Okay. Okay, so the code that the GitHub guy proposed was this one,
Let's see.
which, as
His
Nathan said, it seems to be very inefficient.
yes.
Yeah, the accumulator
Let's
is
see.
basically accumulating
Yeah.
the. Yeah.
Mm-hmm.
And then you check if the new member is actually inside the
Actually,
accumulator.
yeah. There's yeah. At least it's tail call. It has tail call.
Yeah, it is
It's
still cool. Okay, we have our unique then. So let's continue this.
man, you're literally like pasting.
Oh, but we don't have this version of the
What
unique, man.
the fuck?
oh yeah. Well,
Oh, fuck.
and I don't want to edit. I don't want to make it exist.
Wait,
So we're gonna have
wait,
to
wait,
map
wait.
it then. We're gonna have
Yeah,
to
just do it. Yeah, just map
map
it.
fun, and then in the future we're gonna have the type and the type.
It needs to be between this.
Yeah, but what's the order, Nathan? Should the parameter label be on
Doesn't
the?
matter, man.
No, that's why I'm asking. What do you prefer?
Well, I don't know. I would put type as the second, right? But
You
Type as the
put type
second.
as the first.
Type as the
just,
first.
just, just to counter me, man. Look at that. I know that he prefers as the second.
Okay then, so this is gonna be like this, I
Wait,
guess.
wait. Do you need these on the anonymous functions? The dot after the end?
Yeah.
Oh,
No,
wait.
the dot I don't know. I don't remember anymore. Let's see.
No, no, you don't. Don't
Oh, you
inside
don't. You
the
don't. You
yeah
don't.
inside that thing. No, let me
Yeah.
remove the rabbit here.
The rabbit.
And then you have the labels, and then we are comparing that with the length of the labels themselves. And if they are equal, this means that we don't have duplicates. So
Lemons, why don't you find the name of an animal to this, man? They call the operator in F sharp a fish, man. So that's the rabbit. Why don't you?
which, by the way, F sharp copied Haskell because Haskell has the fish first.
Well, okay,
Uh,
but I mean, you need a name for of an animal for that. Maybe it's the tail of the rabbit, you
Actually, the
know?
fish is not even from Haskell, man. That's just like 60s functional programming.
I would believe that because like it's like legendary name. Anyway, if we have a
You're
length of
talking about
the,
the Claysley.
I already
Hmm?
forgot how to do the then. How to do the then?
It's a really weird name, isn't
Well,
it, Magneto?
about the
Like
then.
Yeah, you do
Wait,
just
what?
like this.
the
Oh, okay.
operator names.
Then if they are equal, we don't have duplicates. Then add the type parameter to the env with the parameter name. Okay, so this is what we did before. So let me copy paste.
Claysley arrow.
Yeah, the Claysley fish.
Okay, so let's pick this and copy here. And okay. Okay, so what should we do here? We should pick the labels.
And F sharp didn't copy Haskell because that doesn't exist. So just saying.
Oh.
What do you mean doesn't exist, man?
Well, that operator, the arrow, the Classley arrow, it doesn't
Oh,
exist. It's not
oh,
like
yeah, okay.
defined.
Okay, so add the type parameter to the env with the parameter name. Isn't that like map from list just normal from the labels? I guess.
Uh,
Does that make sense?
I
I'm
don't
going crazy.
know.
What we need to do is the following.
Probably.
What we need to do is the following. We have a list of
But
labels
you
which is composed of types and names. We need to add to the environment the parameter with the type. So we need to transform this list of tuples into a dictionary, to a map.
you yeah.
So
But
the
actually, the best way to do it would be like a fold, adding them to the
Yeah.
environment, right?
no, let's do that. We have fold.
I'll go have dinner. I'll be back.
Just one thing, Magenta. We do have the Claysley man on Haskell.
In F sharp?
No, in Haskell.
No, yeah, but I'm saying F sharp. We don't have that in F sharp.
Wow. We kind of do like, but
No,
yeah.
yeah, I just saying like the same symbol name. Like that's my point. Like we don't
Oh,
have
I
that.
mean, it's from a library, right? Not from F
Okay, yeah.
sharp itself.
Yeah, but like we just define it.
Oh yeah, if
Anyway,
you are really Chad and want your team to hate you, maybe, unless they are
no,
Hasklers
dude,
also.
like no, I say like for example, like you can just define it on the bind. Like for example,
Oh,
like
No,
what's the
what
problem?
I'm saying is yes, but if you want your teammates to hate you, unless they are Hasklers also.
Oh, okay. I totally see the point. Just because it's Haskellers, that shouldn't be implemented, right? Anyway, I'll be back. I'll just mute here.
okay. We are alone now without LSP, just for the record.
Man,
Oh,
I'm just seeing a screen of a bunch of like white text, man. I don't even have highlighting.
no, I don't have highlighting because it's a web version here. But now we have a problem. Do we have folds for maps?
What are you talking about, man? We are folding over the list.
No, no.
Map is the accumulator.
We are. Can you say again?
We are mapping over a list. The map, it's the accumulator.
Oh, okay. Okay, now that makes a lot of sense. So we're gonna have to make the function at some point, but that's okay. So the accumulator is gonna be the environment itself. So environment, and these are gonna be the labels. We just have to make the function now. The function will be. I already forgot again how to do that. Let me check. Okay, it's gonna be like this. No, here. Okay. Okay. So it's gonna be an element, which in our case we can pattern match already here, which is awesome. So you're gonna have what you said, the name on the left and the type on the right.
Right? Isn't that natural? Like, what is the first thing that would come to your head? Like,
Um, that depends
huh.
because I think that
What is the language that you write the type and then the name of the parameter?
C.
No. Wait. Oh fuck yes. Is that the key? Oh no. Holy see, man. Oh no, man. Are you just? Oh fuck. You do right? Like int x in the parameter.
Yeah.
Okay, a sane language.
Ah. There he comes. Now we here he comes the whole hater. Again, if I was editing this properly, I would put the hater emoji from the server right now on the screen, just for lols.
Anyway.
Yeah.
Oh man.
Uh. Okay. Okay. So I don't know. Temp map. Let's create a new map to fuse them together. Then after. So it's gonna be like this. No, wait. But we don't. We already have the entries. We can just append, as far as I can tell.
Well, yeah, you were thinking regarding constructing a map
Yeah,
and then merging them,
yeah. Because
but you are
that's exactly the strategy that we follow like all the time.
ah
Maps
not sure if
append.
it's the same case, but yeah.
Okay, so do we have maps append? Okay, it throw me into a whatever. Okay, maps. Okay, we have a module called maps. How do we have insert? Insert would be cool. Uh, intersect? No.
Mm.
Iterate?
By the
No.
way, like the same thing is the map to always work in a certain way, but as is Erlang, we need to guarantee some stuff, man, like foreshadowing, right? So you kind of need to add in the same end that you are getting from. So
Wait, can
if
you?
you are,
I don't
yeah.
think I get it. Can you repeat?
So you know that the map, let's suppose, is implemented as a list or something to make it easy. Like they have like ways that what you are inserting and getting could be inserting or getting from, right? Like either the beginning or the end in the case of a list.
Yeah.
In the case of a list, when you are adding something to the environment, you are doing like a append on a list, like on the head, right? It's the most normal way. And when you are searching, you are like searching beginning through that head.
Mhm.
That specific way to do the map, it guarantees the properties of shadowing for us. Because if we add something later, it will be in a place where we will find it first, right? So shadowing will work. But if you implement in another way, like a weird way that Erlang might do it, then we are screwed, right?
Wait, I'm having a hard time understanding why we want shadowing here.
Well, because if X is already in the environment, but now this function also has X, then when we put on the environment, we want from the inner X to be the X of the inner
Oh,
function, right?
shadowing the sense of overriding the map.
Yeah, yeah,
Okay. Um, yeah, that makes sense. We want shadowing then, right?
of course.
We want to be able to override, as far as I can understood.
Sure.
Yeah, that's a good question. Let's read the documentation. Associates key with a value and inserts association into map. If key is already exists in map, the old associated value is replaced by the new value.
Nice.
Okay. Okay, this step is now done. So type check the body using the new env. So we just call type check, and then we put
Is
type.
there the right of the put, like the identifier and then the element?
Yeah, it's the key, the value,
Oh,
and then
nice.
the map. Um, and then to type check, we basically put the new environment, I guess, and we put the what is the thing that we need to put here? Oh, the body.
Body.
Yeah, and that's it.
Yup.
Yeah, we are 100% sure this does not compile, but
I'm
well,
thinking about.
there's an else here that we need to take care, which is just an exception. So just copy paste this. So
Wait, we might need to care about something. Just
there
maybe.
are duplicated names in abstraction, and then we could.
Wait, just a bit, Lemus. Like, you agree that if the parameter is variadic, then it changes its type inside the body?
Oh, we need to pass this also, right? The variadic info. You,
No, like, well, what is variadic info, by the way?
it's the information if it is a
Yeah,
variadic
but
or not
that
variadic
info.
function.
Oh, just a tag, right?
Yeah.
Okay. Yeah, that also, but that's not what I'm saying. Like, for instance, let me write the following function here. Oops. Uh, so in that case, what is the type of x in the body of that function?
Uh, int.
Uh, oops. What about now? Suppose this is the marker for variadic.
Now it's a list of ints.
Yes.
What does that mean?
Well, that means that we need to treat this case.
Oh, this means that we need to change the interpretation.
Wait, calm down.
Ah,
I think there are more than one way of doing that because man, we already
sorry,
had the
just
type of a list, right?
yeah, in like
Yeah,
in the low
then
level of the thing we already have, but
no, I
that's
mean for the user. Like even if he doesn't. Wait.
Back.
oh yeah, it is the same. The list is the same. Yeah,
No, what I'm asking is,
even
are
if
we
it
introducing the list in the language?
no, the list is being used both for variadic and non-variadic functions.
No, what I'm asking is, uh, how can I say? Will the user of our language have the list available to him for him to use? Right?
Can you repeat?
Are we adding lists in our language?
That's a good question.
Do we have it already? I don't even remember. Do
Uh,
you know it, Magetta?
I didn't get the question. What are you guys
If we
talking
have
about?
lists in our language.
Well, we don't have it encoded.
yeah, we don't have it encoded at all.
Oh, okay. Like abstractly, we will have it, right?
Yeah.
Yeah,
So if we have list, let's assume we have it. Then we have a type for lists. Then we can just wrap it like.
there is a problem with this that I just
What is it?
noticed. So
Hmm.
this guy here, Nathan, this will require a new type, like a new pattern matching in here, right? Because before, when we were passing from abstraction to application,
No, sorry, man.
this
Sorry. Sorry, I'm fucking dumb. I forgot to write it slash tell you. But this will give you the return type of the function. Then you need to mount the type of the function itself, right? This is only the return. You need to then assemble it, like parameters, return type, right?
wait,
And here you have the variant information.
wait, what? Wait, I'm
Yeah.
confused right now.
So what is the result that you have here on the line 49?
Ideally, gonna have just an error or a type,
Okay, but the type of what?
the type of the body.
Yeah, but what does the type of the body says regarding the signature of a function? Only its return, right?
Yeah.
So that's not the type of the function. We still need to assemble it here.
Ah, that's true. Oh crap.
Uh, I forgot what I was thinking. Okay, yeah, but you know that we don't have type operators, right?
Yeah.
But that's something that the list kinds of need, right?
Yeah.
But we don't need it. Like only if the user wants to do it. So the user, even if they have ADTs, they will not be able to do a generic list. Uh, well, they don't have type operators, and they will not even have recursive types for now, right? Uh,
Yeah, no, but you're going too far. I want to go back a little bit into what you said. We are
okay,
evaluating the body in a way that, okay, I agree. This is not type checking the function. This is type checking the body with it, which is just a return type. So what we need to
Um,
do,
the
in
parameter of unique is wrong, by the way.
the parameter, what is the parameter of unique? Is on a list.
Call to local imported function is illegal in a guard.
wait, what?
Let me read your checker screen. Call
Call
to
to local imported function unique one is illegal in guard. We need to assign this garbage to another thing.
What the fuck?
That's
Wait, what?
Don't question. Just don't question.
What
Just follow
the
orders.
fuck, man? If,
that's
wait, if that,
Don't question. Just follow orders.
then wait, that doesn't make sense. Like your
It
if
works.
here.
it works.
What the fuck, man?
Wait, yeah,
That's a
but
weird
yeah, but
language.
this is not compile anyway because we need to fix what Nathan said. Because Mageta, just look at here. You this? Do you agree that this is type checking the body using the new environment, right?
Yeah.
But then this is just getting the type for the return, right?
Mm-hmm.
Like return type.
Yeah. Mm-hmm.
Yeah. So then we are not creating the type. We are not type checking the function, like the abstraction. We are just type checking the body of it, right?
No, but the body of it is the return, right?
No, the body is the
Yes.
Oh,
return.
yeah. No, but I mean the type of an abstraction isn't just like a tuple of parameters plus a list of parameters plus the return type.
Yes, pretty much. In our case, we have the variable information, right? But that's it.
Yeah, but I'm having a hard time understanding.
But it's just to return the node exactly as Mageta said.
But
Something
didn't we already? Wait.
like this.
Oh, now it makes sense. Now it makes sense. This is a function. I'm dumb. Okay.
Wait, but you need the tag for the name of the node, right? Like
Yeah, we need a tag.
arrow type
Yeah.
or something.
Yeah, I don't know. What's gonna be the name of this, man?
I don't know.
Function.
I don't think we need that.
Well, how do you know that this node is a is a
Oh,
function?
we can
We need that on the
assume.
application.
Yeah, but we can assume that a structure that is evolved in the bottom with this structure is already a function.
Wait, can you
Oh, that's
Like
true.
say that
That's
again?
true.
if we evaluate something, if we type check something and it finishes
Uh-huh.
evaluation, then that means that it's already a function. That's the only thing
You
that
mean
would
with
have this
this
structure.
structure, right?
Yeah,
Yeah, with this structure.
because the only other structure that we have, not is this.
Man, but that's wait. Can you explain this structure to me? Wait, let me follow Mageta. I'm following Lemos.
Here.
Da, 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 da. Go there on the thing that you wrote, the node that you wrote.
Yeah, because all the other structures are like integer,
No,
floats. That's
yeah,
it.
but I'm trying to understand. Like, go on the one that you wrote.
Nathan, I think you forced me to follow you. You didn't
Oh man.
follow.
What?
Yeah. Okay, now it's
I
fine.
can I don't think I can do that.
No, you did. But anyway,
Okay.
go on, Magata.
So that's the node, right? So this is which part, Mageta?
The parameters.
Okay, like this
And
can be like a list, right?
yeah, and let's do
That's the
we
return.
we always just return one thing, right?
Ye-
Yeah.
Yeah,
So yeah. So that would be.
I then the info. Okay, I see. But man, that sounds a bit scuffed because wow, we can adding structures and we will depend not on the tag but on the
On the structure.
yeah. Like if we have another with like three arguments and the second one is a list, we are fucked. Like that sounds
Well,
more
not
insane
really.
than dynamic language.
Not really. Why would that be?
Well,
I didn't get your point.
okay. So you are only relying on this structure. What is this structure in particular? Tree stuff. The
Mm-hmm.
middle one is the list. If you match it as a list, uh, that you don't necessarily do. So you probably only do like,
What do you
well,
mean, man?
okay. You have a tuple, well, a
Yeah.
triple, right?
Yeah.
So you are relying that, oh, the only type node that we have that is a triple is this. That's your guarantee?
Well, no, that's the guarantee. Okay, I can see the points because there could be like a tuple, right? But that would be another type. That would be a type tuple. I think, but
Yeah,
I
like
agree
a
with you.
tag could distinguish that.
Yeah, yeah, I see the point. Yeah, I think a tag would help. Oh
Wait,
man, but I don't want to add a tag.
No, wait.
Lemus knows Erlang, man. Don't worry.
Oh
Wait,
yeah,
can you repeat?
He's our
Can you
writer.
repeat again at why the not using a tag is problematic?
Magetta King.
yeah. Like for example, here, like we are relying that this info. I mean, we could distinguish by the variadic info, but anyway, uh, the point here is like this is a triple, right?
Yeah.
How we are gonna distinguish this triple from a real triple? Like because there could be a type that is like
Oh,
you see.
makes sense.
Actually, we can distinguish not that because like we have the variadic info, which is well unique to
And
functions,
it's a tag.
and the second thing has always to be this. So for example, it could be
No, this is a list.
Yeah,
no
this
no
is a
no.
list.
This is a tuple.
No, that's a list.
In
That's a list.
Erlang, this is a tuple.
No.
No, no,
What
no.
I mean is that there should be a list.
Yeah.
Okay, I see. Yeah, I agree. I agree.
But you're right. We could distinguish by the variadic info. But take a look. In other cases, we can't. So, for instance, think about the type of a tuple and the type of a list. They are the same structure.
Mm-hmm.
So there we would need a tag. And
Or
if
we
we
just
have a
handle
tag,
tuples as we don't have tuples, we just have lists. That's it.
well, yeah, but then it could like be the same with
No, but
records, you know?
we're limiting our language out of laziness. Let's not do that.
No, 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 no.
Hmm?
Why did you do that? No. Ctrl Z.
What, man?
No.
No, because you had the structure there.
Yeah, I just add a tag. No, no, no. Undo. Yeah. Just put function here.
Okay, so here we have to return. Oh, but wait. This is the only. This is an only thing, right?
Hmm?
This is an only thing.
An only?
Yeah, this is alone.
Yeah,
It's
this is
Oh,
just the
alone. Yeah, this is
boolean,
alone.
like.
alone.
This is
Oh,
alone.
okay.
Yeah.
But what do you mean by alone?
Well,
Like we
it
don't have
doesn't.
other types yet?
Yeah, it's not like packed in a tuple.
Yeah. Well, it is packed in a tuple, right? But it's unique. We don't have anything like it
We can do like Python unique tuples, like
Oh,
that's beautiful, right?
oh,
Beautiful
okay.
syntax.
I got what you.
Okay, so okay,
Oh,
and
that's
then
good music, man.
fanfare.
Wait.
It remembers a little bit of Zelda.
This as well.
Wait. Now we have a thing, people, because didn't abstraction call the application before? Or I'm going
Hmm?
crazy.
Wait, I'm following some buffer.
I think that the application and the abstraction they were kind of together, don't they?
I have no idea of what you
The
are.
abstraction and the application, they're kind of together. Well, yes.
Oh yeah,
Not.
the abstraction it was generating a closure, and the closure was being grabbed by the application. Uh, is that
Wait.
a thing?
Wait. Can you show me the part of the code, Lemos, that you are talking about?
Yeah. So are you following me?
Yeah.
Okay. So here, so we have evolve with environment, and then we pattern match
Mm.
to have an abstraction,
Mm.
and this abstraction is generating a closure out of it.
Okay, sure.
That's fine. And then we have the only place where evolve closure is being called in this is when we evolve an application.
Mm. Okay. What about it?
So there is kind of, it's almost like the abstraction is generating a closure to the application to grab it later.
Yeah.
So my question is, do we
Sure.
have to do some sort of like the same behavior when type checking?
No. No. No.
Okay.
No. No.
Okay.
No. Not at all.
Okay. Um. Okay. So what else? We did condition. We did abstraction. We have application here.
Oh no. Oh no. It's like already 9:20, man. Holy fuck.
Yeah, we have
I think
only 60
that's
minutes.
the.
We can stop for now. Let's just see
I
if this
think.
compiles. Magetta, please do this. Let's see if this
Uh,
is not gonna break, like explode.
should we save this that we were doing? No, right?
No, I
Let's
don't
just
think
ditch it.
so. I don't think so. That's the purpose of the recording, right?
So next section, I think we can finish doing the finishing this with the application, we also lack the variable, right?
The variable.
Yeah, the
Uh,
variable is easy. We just get the variable in the environment.
Mageta, my question
Oh,
is,
okay.
can we?
What do you mean?
Can we? Because
Hmm.
like we have a few more things to do, man. Like for instance, we need a comment on the type check abstraction. That is something that we are not doing. That is when a thing is variadic, its parameter type on the body will be a list, right? And yeah, and also if we want to do that like in a okay way, we need then to add lists on our language, right? And for that, we need to add other type, then type check
Yeah, but
the expression of a list.
we're gonna
Yeah,
discuss
it's
more
fine.
things later. That's fine.
Yeah, but do the
What's the
comment,
thing?
otherwise we will forget the caveat.
Comment right there.
How's the thing again?
Percent.
Percent, yeah. Just one,
Check.
I think, is what you
Just
need.
one?
Let me see. I think it's just one comments. Yeah,
Yeah,
this one
one's
already
comment.
comments.
Sorry.
Oh, okay. So, oh, I'm following Lamos, man. Okay.
Dangerous.
Oh no. Okay. Uh, when the parameter is variadic, it needs to have the list type on the function body. When the parametric is variadic, it needs to have the list type on the function body. Oh, it's because. Oh, okay, yeah, that makes sense.
When the parameter is variadic, it needs to have function body. Yeah. Okay, so can I commit this?
Yeah.
I don't want to. I don't want
Oh,
to
do you
test
know what's
this.
the best part? I
Hmm?
think that the test will all fail now.
Yes, it will. That's what I was about to say. Like, I don't want to test all of this.
Lemos, it's like one section for correcting the unit testing and the other for doing stuff, man.
I will try to
Uh,
fix the tests like before next Friday, I guess.
But it's kind of weird because you cannot really. Oh, wait, actually, they will not fail. We didn't change how evaluation works.
Yeah,
good.
but
I
didn't
think.
no, but we added a thing. We added the labels. Oh wait.
Hmm? No, we didn't.
Oh, the tests are considered the old way. Yeah, they shouldn't fail. Yeah. Oh, now I
Good.
should you should stop sharing your screen, or I should stop looking at it. 1 second. Yeah, you can do your
Man,
stuff. I
we're gonna suffer so much. The code generation, I can tell.
I don't think that's the worst part.
Yeah, that'll be hard.
I get the Nathan
I think this
always says this.
calculation did when
Hmm?
it
I
changed
always
the
say
now, right?
that.
Yeah, you
It
always
changed the now.
says that code generation is gonna be fine, parsing is gonna be fine. The real big deal is
Hmm.
compiling. It's always
Wait,
like this.
what you said doesn't make sense.
Yeah, it's exactly.
No.
Yeah.
What you said is, I think it's easy to code generation, but it's hard to compile.
No, you said that we're gonna have
That's what
more
you said.
problems with
Type checking, you mean?
type checking.
Yeah, I say that indeed.
Magetta, were
Hmm?
you showing sensible information in that terminal?
Which terminal?
It's because you're using the terminal from VS Code, which I do have access to.
No.
Oh, nice. I already deleted, so it's fine. Okay, Nathan. Maybe we're gonna have you also think we're gonna have problems in code generation, but you always said that we're gonna have
Wait,
problems
I
in other
think you are.
places. More problems in other places.
Well, yeah. So let me do like three statements. We have gonna have problems everywhere. So that's one. The other is I think the type system it's the hardest one, and the other is I think that code generation and parsing are not as cool as type system. They are like three independent statements. Maybe you are like mixing some.
Pushed.
Okay, so I
Oh,
just